Hi. Today we're going to talk about systems of equations still, but now we're going to talk about solving them using something called the elimination or combination method. So we're going to do solving systems by elimination, otherwise known as combination. As we go through this, please consider what the words elimination and combination mean. I think about combination meaning adding, and elimination meaning that we're going to eliminate something, make it go away. And you should see that that's exactly what's going to happen. So if I were to give you the system of equations 3x plus 3y equals 18 and negative 3x minus 2y equals negative 16, the first thing that I would do, as I've asked you to do before, is take a look and see what there is to see. In particular, I noticed that I have x's, and then I have y's, and then my equal signs, and then regular numbers on this side. In other words, everything is all lined up, which is really important. So, since I see that, the next thing I'm going to look at is, do I see any numbers here that kind of draw my attention? In particular, I see a 3x and a negative 3x. And remember that this is called the combination method, which means add. So think about what would happen if I added these equations together. Knowing that I have a 3x and a negative 3x, if I actually show that I'm adding these equations together, notice that 3x minus 3x is 0. These get eliminated by adding together. So then I would just add the rest of the things. 3y plus negative 2y is just a plain y, and 18 plus negative 16 is simply 2. So in one step, because of the way it was set up in the beginning, I got y as 2. Now the only thing I have to do is go back and get x. So I would choose either equation. I'm going to choose the first one just because I like it. So I'll choose this equation, but now I know that y is 2, so I'm going to plug in 2 for y so that I can solve for x. So this would give me 3x plus 6 equals 18. Subtract 6, get 3x equals 12, divide by 3 so that x equals 4. So with that, I have a solution, or a point of intersection of 4, 2, remembering that it's x then y. This is the elimination method. It just so happened that everything was lined up and my x's were additive inverses of each other, meaning they were exact opposites, positive 3 and negative 3. But keep in mind the first thing that I did was looked at the problem to see what there was to see. So if I was to give you something like 4x plus 6y equals 10, and 12x minus 6y equals 6. Again, the first thing I'm going to do is see what there is to see. I notice that I have all my x's, all my y's, my equal signs, my regular numbers. Everything is lined up. I also happen to notice that this is a positive 6y and a negative 6y. They are exact opposites of each other, meaning that if I were to add these two equations together, my 6y and my negative 6y would add to 0 because they're additive inverses. So now I just add the rest. 16x plus 12, or 4x plus 12x is 16x. 10 and 6 is 16. Divide by 16 and get that x equals 1. Of course, now I have to go and find y, so I pick either equation. Again, I happen to like the first one, so I'm just going to do 4, but now I know that x is 1, plus 6y equals 10, and I'm just going to solve. So 4 plus 6y equals 10, subtract 4, 6y equals 6, divide by 6 so that y is 1, and now I have a solution. Remember, that really means the point of intersection is 1, 1 on the graph, even without seeing the graph. Pretty neat. Okay, so something slightly different, if I give you 12x plus 20y equals 24, and then 12x minus 6y equals negative 15. I had mentioned that that might be something slightly different. Consider what's different about that. I see everything lined up, my x's, my y's, my equal signs, my numbers. I see a 12x here and a 12x there, but they are not opposites. They're both positive. If I were to add everything together right now, this would give me 24x and 14y and 9, but that doesn't help. This is supposed to be called the elimination method. I want to eliminate something. If I add these the way they are right now, nothing is eliminated. So what can I do? I'm used to seeing from the other two examples that one thing is positive and one thing is negative. And yes, I do have a positive and a negative here, but again, those don't cancel each other out or eliminate when we do anything. However, if one of these 12s was negative, that would make it possible to add something and have it be eliminated. So what I'm going to do is multiply this bottom equation by negative 1, because doing that gives me negative 12x plus 6y equals positive 15. Notice that I multiplied everything. I basically distributed a negative 1. I don't have to mess with the top equation, so that's 12x plus 20y equals 24. And notice what I see now. Now I have a pair of exact opposites, positive 12 and negative 12. So now I am actually going to show that I'm adding these together. The 12x's go to 0. 20y and 6y gives me 26y. 24 and 15 is 39. Next I divide by 26. 39 doesn't divide nicely by 26, but I can use my calculator and I'll get that it's 1.5. Or you could even leave it as a fraction, which would be 3 over 2. So now I know y. I still need x. I'm going to go back and do it the same way I did before. I'm going to choose one of these two original equations. I like the top one, so I'm just going to do 12x plus 20, but now I know that y is 1.5 equals 24, and I solve. So I get 12x plus 30 equals 24. Subtract 30 and get 12x equals negative 6. Divide by 12 and get that, x equals negative 1/2. Oh, so I do have fractions on these. It doesn't change the way I think about it. It just means I have to handle the fractions. So my solution here is the point negative 1/2 comma 1.5. Again, remembering that it's x and then y. So sometimes we have to manipulate the equations just a little bit to make it so that this process actually works. Okay? Let's take a look at just one more together. So if I give you 4x plus 10y equals 22, and 45x plus 10y equals negative 60. Again, take a look at what there is to see. I notice that I have my x's, my y's, my equal signs, and my numbers all lined up, but I don't have a pair of opposites. Luckily, I do see a positive 10y and a positive 10y. I can easily make one of those things be negative. I'm going to choose to multiply the first equation by negative 1. Please recognize I noticed that that's a choice that I'm making. I could have chosen to multiply the bottom one by -1. This would give me negative 4x minus 10y equals negative 22 because I'm distributing the -1 to all three parts. I don't have to mess with the bottom equation, so that stays as 45x plus 10y equals negative 60. Again, the purpose of doing that, now I notice that there are exact opposites there. So I am going to add the equations together. Negative 4x plus 45x is 41x. The 10y's go to 0. And this will give me negative 82. Now I divide by 41, and I get that x is equal to negative 2. Not that bad. So then I'm just going to take that and substitute it back into one of the equations so I can find y. This time I'll use the bottom. So I have 45, but x is negative 2 plus 10y equals negative 60. 45 times negative 2 is negative 90 plus 10y equals negative 60. Add 90 to both sides. Get 10y equals 30. Divide by 10 so that y is 3. So my solution is the point negative 2, 3. Most of the time, the elimination method works out pretty well, especially if you're given equations that are already lined up nicely with each other. So this is what we're going to be working on for the next couple of days. In preparation for class tomorrow, I want to give you 3 of these to try. Please use your notes that you've already taken to help you go through these. So number 1 is going to be 3y minus x equals 2, and 3y plus x equals 16. Number 2 will be 2x minus 3y equals 4, and x plus 3y equals 29. And then the third one is 2x plus 7y equals 29, and 2x minus y equals 5. See if you can apply the concepts of elimination or combination to those 3 problems, and I will see you in class tomorrow. Have a nice day.